Okay.
Thank you, David.
Well, thank you very much for being here. It's the first opportunity that we actually have to give you a little bit of insight into the nature of the work we do. And what is important is that we want to indicate to you, well, basically, as you all know, we are 100% research appointed. But we are involved in teaching. And the important thing is to show you how we actually combine teaching and research. And that's the important part. And we're going to talk a little bit about our research, but also our teaching. How we get research publications out of our teaching. Now we'll talk about that right at the end. That's about 12 o'clock tonight. Because I'm lecturing with a glass of wine. So this is basically an introduction, a very quick one that you all probably know. The 6 blind men and an elephant, all touching different parts of the elephant. But as you can see, the one feels a fan, the other one a snake, the other one a building, the other one tree trunks, and so it goes on. It's a partial truth what they see, because what they need is, what we need here is a holistic view to really know what is this thing. And the behavior of a system cannot be known just by knowing the elements of the system. Just a few system definitions for those who are interested. A system is a set of elements or parts that is coherently organized and interconnected in a pattern or structure that produces a characteristic set of behaviors, classified as its function or its purpose. Another one simply defined a system as a complex whole, the functioning of which depends on its parts and the interactions between those parts, like a motor car is a system, and its functioning depends on how the different parts of the motor car actually interact with each other. A system is more than the sum of its parts. It is actually the product of their interactions. A system versus a collection. I mention this because it comes up a bit later. This is not new at all. A collection is also composed of a number of parts, but they are just dumped together and are not interconnected. For example, a marriage, is that a collection or a system? Honey, are we a collection or a system? And he hopes we are a system. A degree or a degree program, for example, and we'll come back to this. Is a degree program a collection of courses dumped together, or is it actually interconnected to form a system or a real program? The basic properties of a system is that it must consist of elements or parts, interconnectedness and interactions, function or purpose. Examples: a business, a company, football team, digestive system, the business school is a system, faculty is, city, corporation, animal, a tree, etc., etc. Now that was a system. What is the definitions of systems thinking? That is, systems thinking is a way of looking at learning about and understanding complex situations. It's a way of seeing and talking about reality that help us better understand and work with systems to influence the quality of our lives. Systems thinking is a new way of thinking to understand and manage complex problems. not really a new concept, but the way in which we take systems thinking into practice today is very new. Dealing with the complexities and coping with the increasing market dynamics have become major challenges for managers and decision makers. Climate, environmental, social, political developments, disruption of the value chain, global information exchange, all these kind of things make that we all work in very complex environments. Whether we operate in our homes as families, or whether we are a CEO of a company, or the Premier of a state, or the Prime Minister of a country. You see these kind of headline issues every day in the newspaper. Climate change, energy crisis, food crisis, environment, carbon emissions, water shortage, food safety, globalization, sustainability. These are all headlines. And what we tend to do is to tackle these problems in isolation. In reality, if you try and put those same things together, you can actually develop a very simple systems model, because all those things are actually interconnected. And in some way, they are, if you tackle one, an economic or a health or a financial crisis problem, and you tackle it only in one way, in a silo, the only way you will get somewhere is by looking at cause-effect type of things, and you put band-aids on. So we actually operate in a very torn net. Everything is linked to each other, everything is interconnected, and with regard to this, we will actually in our teaching, we have a game that the students will play to see how you cannot make one decision and think that that will solve the problem. Everything is interconnected. You make one decision and you actually affect every other part of that system. So making decisions in such a complex web of interactions, politicians, business managers, and actually all members of society have to make important decisions on a daily basis in the complex web in which business, social issues, finance, economics, environment, politics, culture, they are all highly interconnected. Do we actually get it right? Do we make the right investment decisions? Are we aware when we make a decision of the unintended consequences, or are we only thinking about the intended consequences? How effective are we in our cross-sectoral communication and collaboration to deal with multidimensional nature of complex problems? Do we go for quick fixes because it's easier to treat the symptoms? And I'll come back to this. Or do we urgently need new and innovative ways of thinking and a fresh approach and tools to deal with the problems facing our society? Systems thinking and a new way of thinking, where the world is dynamic, evolving and interconnected, we tend to make decisions using mental models that are static, narrow, and reductionist. Narrow focused and isolated solutions often lead to policy resistance and unintended consequences, things that we have never expected will happen. We have to balance and integrate short-term and urgent solutions with long-term systemic interventions. create resilience, collaborative, integrated and systemic approaches to enhance cross-sectoral engagement, communication, collaboration in dealing with complexity. This is what systems thinking can give us. Fundamentally, foremost, we need a new way of thinking that allows us to test and challenge age-old assumptions, because we tend to cling to the ways in which we have our thinking is working, our thought processes. Systems thinking are today applied in every area of society: business, commodity systems, agriculture, education, philosophy, sustainability, etc. The basic philosophy behind our systems approach that we are actually using is what we call the iceberg approach, which is a big iceberg lying there, and what you see is just the symptoms, that little part that stick out above the water. And that is the way in which we address our problems. Denmark will give $2 or $3 million for poverty in Cambodia, just to alleviate poverty. That is typically a band-aid. The approach that we use is a systems approach, where we actually start at the bottom, in the deeper layers of this iceberg, where we gather the mental models, the mind maps, how people understand that problem. What do they think? Why do you have poverty? What are the barriers? What are possible solutions? What are the barriers? And identify the real issues, trying to get to the root causes of an issue, such as poverty, or a business that doesn't run in a profitable way, or whatever. The next step is to actually put those mental models into a systemic structure. In other words, what does the system as a whole look like? Doing a systems analysis using the mental models, integrate them into a systemic structure. Once you have a systemic structure, you look at the patterns and the interactions between the different components. Once you're there, you start identifying how to address the fundamental problems to achieve sustainable systems, or to alleviate poverty, or to make a company more profitable, or an organization to work more easily, or a family to be less dysfunctional. And then the dollars go for root causes of poverty, and maybe mitigating the effects of tourism as a mechanism for alleviating poverty and so on. But that is where the dollars should go, and not to the level of symptoms over there. We have various systems tools that we will be teaching in our programs. Causal loop modeling, Bayesian belief networks. We have installed that on the University of Adelaide server. Evolutionary learning laboratories approach, which I'll talk a bit about and show you how that works. The sensitivity model of Vester, which is the basis also of the simulation games that we play that we will play with students. Behavior over time, system archetypes, stock and flow diagrams, and system dynamics models. To mention but a few. Now, I'm just going to give you a few examples of the nature of these models and what they are about. Causal loop modeling, for example. Step one is gathering the mental models to identify the variables. That's the end result of a workshop with about 80 people, and what you get is themes starting to appear, and these themes are very important when you develop a model. And at the end, you start looking at what leads to what, and that thing will lead to something else again. And it starts to form reinforcing loops, it starts to form balancing loops, and all these kind of things. We're not going into the detail of that. That is typical the system structure. So you can start looking at how the number of tourists will influence tourism revenue, will influence GDP per capita, the livelihood of the commoner, which will address poverty. Number of tourists could cause a lot of waste. Tourism pollution, that could affect the attraction of the island, and then that could affect again the number of tourists. And so you can start looking for patterns and different things that you see in the model. The whole idea is to understand the systemic structure. And in this process, we build into this process a lot of capacity building. People who didn't even finish school will actually put these things together and start to understand, because it's one of the most effective ways to understand and to develop a shared understanding of the issues and the goals, that shared vision that they should have. Then you can start identifying patterns and relationships, looking at tourism increasing, pollution increasing, the environment's going down, poverty stays the same, and this starts to tell you a lot about the system. Linear thinking. If you ask someone today, how can we, on Cat Island, which is a very big tourist destination near Vietnam, how can you actually use tourism as an opportunity, as a mechanism for alleviation of poverty? Yeah, enhance tourism, and that will bring employment opportunities and will bring wealth to people. That's typical linear thinking. How most of us would solve problems and try to solve problems. There are many reasons why we do this kind of thing, because you can see, with linear thinking, you can see the end results very quickly, as I'll explain later on. But when you look at systems thinking, instead of linear thinking, you start to see that the number of tourists actually causes lots of problems. It causes waste, pollution, it causes social problems, access to education, land required for tourism, availability of underground water, etc., etc. So what you start having is you're dealing here with a tourism economic sector, with an environmental sector, a natural resource sector, a population sector, all in one system where we originally thought linearly about this problem. And what has become extremely important is the need for cross-sectoral engagement, communication, collaboration in solving problems. Because these things are all interconnected with each other. Leverage point is another part of causal loop modeling. A leverage point is places within a complex system, in a corporation, an economy, or a living body, a city, or an ecosystem, where a small shift in one thing can produce big changes in everything. In economy, the most often used leverage point is interest rates. In a ship, a massive big ship can be changed direction by a small little thing at the back of that ship. Leverage points are points of power, and they are not intuitive. Systems archetypes. A very valuable tool to identify system archetypes to actually find the leverage points in a systems model. They are generic systems models representing a wide range of situations, high-level map of dynamic processes, and reveal a very elegant simplicity underlying the complexity of management issues. System archetypes will always suggest areas of high and low leverage change. And I have just two little simple examples. One is the limits to growth system archetype. And what you see here is that the number of tourists increases tourism revenue, which increases the number of tourists, which increases that, and that is a reinforcing loop. But some constraints over there is actually affecting the attraction of Cat Ba Island. So what you get is you get a balancing loop, which actually balance, because that attraction that is affected will bring the tourist numbers down again. So there's a balancing loop next to a reinforcing loop. It's a typical limits to growth systems archetype. Another one is the international aid, which calls the shifting the burden systems archetype. We have two loops here, two balancing loops. There's problems on the Cat Ba Island, and with international funding, we quickly solve these problems. And that goes around and around and around. However, it's not effective because you don't have long-term solutions. It's all band-aid solutions. But a government, normally, if Australia or Sweden also give money to Vietnam or Cambodia or whoever, they want to see, before they are out of power, what is the, what have I done? They want to see the end result of that. So what happens here is that to solve the problem is in reality a long-term solution to solve. But what happens with international aid is that you get a reinforcing loop where they become dependent on international assistance, which cannot solve long-term solutions. So that is actually a loop that causes, it shifts the burden. Bayesian networks is a very useful tool for participatory systems analysis. It's very visual, it's extremely easy for non-modelers, flexible. You can link both qualitative and quantitative factors. As a matter of fact, you can model completely with qualitative information. It deals extremely well with uncertainty, and when you deal with complex systems, you are dealing with uncertainty. You can do scenario testing, sensitivity analysis very rapidly, and I'll demonstrate that for you. And it's useful for developing action or operational plans. Building a Bayesian network, there's diverse mental models out there. Think of that triangle that I started off with. There's diverse mental models out there. We can develop a conceptual model of the system, how it all fits together. Then you can, for example, take a particular issue that you want to resolve and build a decision-making Bayesian belief model for that. The Bayesian belief models integrate the mental models. It integrates disparate forms of knowledge and data. It's useful, as I said, for participatory systems analysis. It represents complex systems. It's updatable all the time, and scenario and diagnostic and sensitivity analysis can easily be done. What is a Bayesian network? A Bayesian network consists of nodes, those are the variables, and of links representing causal relationships. So A and B is causing C. And then there's it's a representation of graph theory structures, probability theory, strength of relationships between variables. And I put a little bit of mathematics in there that you can't see. Inputs, expert opinion, non-technical, literature, monitoring, research data, other models. That is all the inputs that you can use in there. But I have just put that there to show there is mathematical modeling behind the scenes, but no one have to worry about it. These Bayesian models are being increasingly used everywhere in the world in various different areas. And the way they work is very simple. By doing an analysis where you, participatory systems analysis, where you start asking, you want to improve something, improve the, increase the profit, or you want to improve the how well an organization functions, or whatever the case might be. So the things you can do, what are the kind of things that you can do? And people come up with various ideas. It's a way of unlocking the mental models of people. And then you ask the question, but if you do this number A, what will that lead to that will actually cause an improvement of this? If you do B, what will that lead to? And then the next question is normally, what other factors will be controlling these different things? So you say that if you want to have a clean house, one of the things you're going to paint it. That will lead to clean walls and a clean roof. But what factors out here will actually affect that? And it might be dust. So you can't paint on a windy day because the dust will actually cause this to be even more dirty. The house will be more dirty than what it was before. The next is what needs to be in place. If you want to do these kind of strategies that you see there, A and B, what needs to be in place for A and for B? And in that way you unlock the mental models and the experiential knowledge of the people who are involved, as well as models and mathematical models, hard science, of scientists that are involved. And you can actually mix the whole lot up in this one model. So what you have, you end up with the systemic interventions that you can do, the strategies, the activities, when you should do it, which one comes before the other one, preparation for it, the planning of it all. Basically what you develop is an integrated strategic management plan directly from a Bayesian network model. And I just want to show you one example of such a model. this is the package that we have developed, and we have put it onto the system over here. Where is the example I want to use? Is this one over here. I thought this is a good example because we are actually in the process of doing things with now how can I get this smaller?
It's plastic, man. It's not that you go up further to see it.
Uh,
You have to move up. You go up.
If you make it smaller, we won't be able to read it.
It's in the bottom,
Yeah,
bottom right, isn't
corner
it?
there.
100%.
Yeah,
100% down the bottom.
There you go.
I think it's more or less okay.
Yeah.
I think it's all in, yeah. Okay, that's a typical model, and if you can't read it there, but this is a school, a university school, systems design management, a graduate school at Keio University in Japan, who wants to lift their game. They want to be a world-class school. They have come up with all these different things, making up what will make the school. You ask the questions, what can you do to? They said things like, you know, better alumni relationships. They have to engage better with industry. They have to do good promotion of the school. They're teaching, you know, and they have to do language training so people can. And obviously, they need a budget, and so it goes on. But with the information that they had available, this model was populated. I'm not going to go into the detail of that. But that, at the moment, as you can see, there is only a 60% probability that this school will be seen as a world-class school. So then, with this, you can actually start looking at individual things. You can go here and say, now what you need to do is, I'm going to change, say, is that alumni relationships, and you look at what happens at the bottom in the blue thing. No, sorry, I made the wrong thing. It made a very small change. Can you see there? So that's obviously not something you can do. To make this a bit quicker, I'm going to push that one, and you will see what a big change it makes to the system as a whole. And we already have a 71% probability that this could be. Now, one of the reasons for it, if you engage well with industry, look, you will have good industry relationships, which actually will improve the facilities of the school for research. It will increase the budget. If the budget increases, you know, they have money to appoint a competitive intelligence professional. They can do this language thing, and when they do this, they will have a lot of students, but they don't have very high entry requirements. So if they change their entry requirements, you can see that there's now an 83% probability that this school will change into, will become a very a world-class university, a world-class school, and that is by only doing these few things that's been done there. Now, if you don't make language, you can start going back. Make language, it only takes it off a little bit, so they don't really have to spend a lot on language. The most important in this whole thing is this factor there: engage better with industry, have the correct things to promote so that the promotion can be effective and make their entry requirements more stringent. That's the only things they have to do to actually get an 80%, more than 80% probability to have a world-class school. Okay. You can also do backcasting, but I'm not going to carry on with that. Another example, which we use in the tutorials, is where you can have cost-benefit built into the thing. You can have, say, product development. You're going to develop a new, thorough, new product, thoroughly designed, etc. A new one which you're going to use a rapid program. You're going to just consolidate what you have and strengthen it, or you're just going to keep what you have. You're not going to change anything. Now, that, they said, was very dependent on the market. And if the market is reaction to this new product is good, you can see that the new rapid is going to make the most money, taking into account the cost-benefit utility nodes. However, if the market is very poor, the market reaction to this, it is better that you just do absolutely nothing, because all the others are, you're going to lose money. And so it goes on. These are various examples of how these models can be used. So when it comes to formal education, that is adding value to disciplinary focused programs and offering the degree programs. We talked about this also during the last school meeting. What we are involved in is executive training, short courses in the workplace, at the university, or in the workplace, wherever people invite us to go. Undergraduate introduction to basic principles of systems thinking and practice, developing skills such as critical thinking. You remember yesterday these words came up in Christopher Finley's list there. Problem-solving skills, knowledge management, communication skills, integration, teamwork, dynamics, etc. At postgraduate, creating a platform for integration. There is a need for flexibility in content, mode of course delivery, and way of learning. Because we have different types of students. You have discipline-focused students, you have integrators, you have university students, you have students who are already in the workplace, managers in industry, and so on. And there's different types of learning, web-based lectures, learning laboratories, learning by doing, etc. And when it comes, the common principles in presenting a systems course, when it comes to curriculum design, there is a diversity of learners and ways of learning, which need to be taken into account. Pedagogy, learners learn best when learning activities require them to be actively engaged. And informal learning, learners learn things of value outside education systems. They have something to contribute to education. This is a systems education matrix developed in 2008 at the International Federation for Systems Research, one of their conversations. And along this here is sort of the different types of students, sense-making, practical mastery, theoretical mastery, and then you have, on this way, discipline, integrated, and generic. The interesting thing here is that this is, for example, a horticulturist or an accountant having the ability to use basic systems concepts to make sense of phenomena, objects and processes in the world, be able to think critically. When you get to practical mastery, I think this is where, typically where an Adelaide MBA graduate will lie. In other words, a systemic manager, a systemic financial manager, a systemic accountant, systemic policymakers. And then when we did a brainstorming of contents of curricula, there are so many concepts in systems that people said, well, these things need to be in a curricula. And in the 2010 IFSR conversations at Brunegg in Austria, they came up with these ones where they say systems learn that issues facing the world are complex, straddle many different factors and involve diverse stakeholders, multidimensional, multi-stakeholder systems, and so on. Understanding the context in which the problems arise, cultural, political, and so on, and how the different disciplines fit into that. Understanding how different disciplines are related to the whole, interconnectedness, interdependencies. Learn to address underlying causes rather than symptoms of a problem. How to identify positive and negative feedback across components of a system. So you can see where are the balancing loops and the reinforcing loops to identify leverage points, systemic interventions. Learn skills to address problems that appear to be intractable. Learn about how the changing nature of the world impacts on the way in which people and organizations make decisions. That is basically what was seen as a good introductory framework for an introductory course. Looking at more advanced things, you would have how do you frame issues as problems? What is a problem? How do you distinguish between problems and symptoms? Learn about the importance of ethics and values in relation to contemporary issues such as poverty, pollution, children's rights, etc. Theories of risk and uncertainty. Learn about how the changing nature of the world affects upon the way in which people and organizations make decisions. Learn how complex problems cannot be solved in isolation within single disciplinary boundaries. This is a massive paradigm shift that we're talking about, because our whole society operates like this. We have in our governments a Department of Environment, a Department of Transport, Department of Education, and so on. And we have to operate like that, because that is how an orderly society operates. However, we need to learn how can we actually cross those boundaries. How can we do cross-sectoral engagement effectively? How to use tools to integrate knowledge, and how hard systems theories and soft system theories and integrating systems theories can help this process. How to communicate, work in teams towards the common good. Learn that the traditional forms of organization are inadequate in dealing with increasing complexity, as I've just talked about. Learn that systems are composed of subsystems, how to map them out. Learn about generic patterns of system structure and behavior, such as the tragedy of the commons, shifting the burden, fixes that fail. All of these things are important to understand the behavior of systems and to identify where the systemic interventions are required. Learn about tools for decision making, systems mapping, system dynamics, building consensus. And this is a step that is very often left out in short courses. People learn about systems thinking, new ways of thinking, but there are many tools that are very simple to use, and those are the things that we intend to bring into the curricula. Learn new ways of thinking which enables you to become an agent of change. the New Era Adelaide MBA as an example. We look at the MBA. It's a program. Is it a collection of courses, especially when you can have electives? Do we want to move to a system of integrated courses? If we want to do that, we have to go along a journey of a new experience, a complete new experience, which can be helped with various of those modules that I talked about, and with other information, other modules and lectures that other people in this room also have, from complexity right through to the cutting edge systems tools, and get these different courses in the MBA to actually become interconnected. And that will lead to managers and leaders that are equipped with new ways of thinking, that are systems design-led to deal with complex problems in a systemic, not systematic. It's a complete difference, a big difference between systematic and systemic. To deal with complex problems in a systemic, integrated and collaborative fashion. And businesses and government institutions are making the right investment decisions in the face of a continually geopolitical, socio-economic changing landscape. Infiltrating disciplines with systems thinking, value adding, building essential skills that employers want. One of the models that we have followed in the past very successfully is you take degrees like B Commerce, B Finance, the MBA, B Science, doesn't matter what it is, and all courses have the discipline core. They, I don't know about Adelaide University, but at the University of Queensland, where I come from, all faculties had core courses that the students had to do. And then there's the electives. And the way in which we infiltrate with systems thinking is systems thinking and analysis, knowledge management, problem solving, systems dynamics, teamwork, interpersonal skills, communication, global thinking, critical thinking skills, etc. Were put into, as a course, into the faculty core of some of the faculties. And then students can also run more advanced courses in the discipline core or take them as electives right through the university. At postgrad level, a core of systems thinking, for example, for sustainability or for management or whatever. Systems, sustainability and society, and then designing sustainable systems. We have a cohesive list of courses clustered in fields. So you have systems engineering, food security, safety, environmental markets, business management, even heritage development from the arts faculty, global livestock production from agriculture, resilient communities from social sciences, sustainable organizations, and so on. And they can actually take courses across those fields, share courses across, and there's partnerships between engineering and science faculty, between agriculture, food, science, and business for that one, and so it goes on. But what actually happens is that they get here learning how to unravel the complexity, design and manage complex issues. And in this part, they apply the principles in different areas of interest and different contexts in projects. And the projects are actually in that last one there. Very similar to the what we're talking about in the MBA. Just for interesting sake, this is what one of the postgrad programs look like at the University of Queensland. The class consisted of people in agribusiness, business, master of business, master of engineering, environmental management, natural resource economics, rural systems, master sustainable systems, agriculture, and amongst these others were even there was what was he, a gynecologist studying gynecology, I think it was. Anyhow, it gives you an idea of the variety of students that you can get in there. Just going to the evolutionary learning laboratories, getting to an end now. These, I'm just referring back to this because it forms the basis of the evolutionary learning laboratory technique that we are using. Starting with the mental models, systemic structures that we develop from the mental models, then looking at the patterns, the interactions between that, and go past the symptoms and address fundamental problems to achieve sustainable systems. Just reminding you of that. Because what I want to show you is the evolutionary learning laboratory for sustainable management of Katba Island Biosphere Reserve. Going from mental model gathering to system structure to patterns and relationships. And this is a 7-step process which starts with identify the issues by gathering mental models, models of relevant stakeholders, capacity building, systems thinking, causal loop modeling in order to integrate the diverse mental models into a system structure. A very important step for these people that are involved in government is that they actually do these things themselves, because then they take ownership of it. And they do that because for developing the systems map all the models, and which look something like that. Then they start with the process of identifying leverage points and systemic interventions, looking at issues like that, where they would say, for example, well, there's a reinforcing loop, number of tourists, tourism revenue, hotels, more tourists. That's a typical reinforcing loop that. But there's also a balancing loop there, where the tourist numbers give you more waste, more tourism pollution, and attraction of the Katba Island is negatively influenced, or the number of tourists are negatively influenced by the attraction due to all the pollution. And so they go through the whole system in various ways to identify leverage points, like waste management needs systemic intervention. And they said that tourism revenue, the arrows are there, that leads to what have I done? The tourism revenue, it leads to better alleviating poverty. But they said it doesn't happen. So that became something there for a systemic intervention. And we have worked with them in August. Naum and I are doing some work on waste management, on this particular issue, and so on. And they have identified others. So once they have the model and they identified the leverage points, the next step is to take that waste, for example, leverage point, and use Bayesian belief network models, or we use system dynamic models. For example, we have developed a quantitative model, one of our PhD students, on this number of tourists issue, but developing Bayesian models which then address that particular issue of waste management. And then out of that comes the actual things that you can do. and that forms the management plan, a systemic management plan. And by addressing all the various ones, you start getting all the things and that needs to be done in an integrated systemic, strategic systemic management plan. Then these things are implemented, strategies, policies, and so forth. And one of the most important steps is once it's implemented, there's the step of reflection, where people actually talk about this. How are these things working? Is it working? What are our failures? What are our successes? Where are we going wrong? How should we change our model, etc.? And that actually leads to new levels of learning and performance on the Katba Island. So we have many of these learning laboratories around the world, and created a thing called GEL, and that stands for Global Evolutionary Learning Laboratory. And we work in a team with people from around the world on developing this platform, which is a very high-tech platform. We are very fortunate with people in England and in Canada helping with that. As I said before, we are working in an alliance. Even though we are 3 over here, we are in an alliance with a very large team. And those people help, and we all work together to develop this. And how it works is that a learning lab goes through that whole process, and then the reflection is then shared through the cultural lens of other cultures, ethics, political systems, etc. And the lessons that they have learned, say in one particular country or particular issue, and that is the informal co-learning about complex issues in a global context. But what they learn there can also be taken back to the individual learning labs, and they can use that to continue their cycle again with new ideas that they have picked up through that. Why I said this is, in the past we were dependent on meetings. We had to come together once a year and have a meeting of all the people that work in various learning laboratories, and then share this lessons learned with each other. And what we're doing now is the high-tech platform on the internet, where people actually can share these lessons learned over the internet, and we're not dependent anymore or have to rely only on physical face-to-face meetings, although they still will happen. So that's just illustrating various things. And then also what these platforms do is that we identify projects for university undergraduates, masters and PhD students and other research organizations. When we start sharing the lessons learned with each other, then the questions can sometimes not be answered by yes or no, but we identify a project. And it is very easy to find a scholarship for a student, even from their own governments, to study that particular problem, because you can show in the learning lab how important that particular issue is. So the teaching and learning research we are doing, contributing to the development of the Adelaide Business School as a centre of excellence in systems design and interconnected thinking. The research is carried out at the moment in collaboration with 11, maybe 12 universities around the world, forming a global systems education learning laboratory. And I have to say, most of these are people, we focus on the MBA. Of particular importance is to examine how systems and educational scholars and practitioners can serve sustainability, resilience, social responsibility in business by seeking to create new relationships within and across boundaries of existing social and business systems. In this research program, remember we are 100% research, our methodology will be teaching and learning, different courses, designs, modes of delivery. Subjects are different types of students. Outcomes are graded attributes and outputs are publications. This research is only possible through direct involvement with different forms of systems teaching and learning, with different types of students at both under and postgraduate levels. Looking at the MBA, you've seen that there, that matrix, we have used that matrix, we have used these models that had all those green labels on, and developed these, a first year course, and intense and more advanced modules that will be form a thread throughout the MBA to achieve that kind of MBA, distinctly different from others. Just that same thing again, and that is one of the ways that we were looking at how the different modules can actually fit into the, but there's one particular course, this one here, which is now called something else than transformational leadership, but in that one we will actually play also a strong role to integrate and get these different courses to interconnect. So the Evolutionary Learning Laboratory for Systems Education, we identify issues, we gather the mental models of different systems educators and job providers of the goals, the expected graded attributes that job providers want, of systems education for different types of students, main contents of introductory and advanced courses. We already have a lot of that kind of information. We build capacity, how to interpret Bayesian network models via the web-based, decision-based learning interactive package, the one that I showed you earlier on, in order to help develop and refine systems models using Bayesian network modeling of the factors involved in achieving graded attributes, barriers, potential solutions, drivers of success, external factors, modes of delivery, etc. Then we will identify what drives the system, what are the factors, the leverage points and systemic interventions that will determine the highest probability for achieving our education goals. And we will then have integrated systems curricula for introductory and advanced courses and modules for different types of students, taking into account the leverage points and systemic interventions to ensure successful outcomes. And then we will implement that. In other words, we will offer the courses in these different ways and with the different tools, and we will reflect on that, and the new levels of learning and performance at the University of Adelaide will lead to that. That will be our learning laboratory at Adelaide University. And there it is at Adelaide. We have many different ones, but there is the systems education one, linking then to GEL, the Global Evolutionary Lab, and sharing the reflections with the other universities that's involved in the program. And then just the last thing we do, and I'm not going to say anything about it, I think most of you know about it, we have we talked about leverage points. We believe one of the leverage points for turning a very strong ship, turning a strong ship to change its direction a little bit, is starting with the young, to create new era leaders. People that understand these kind of approaches, that understand linear thinking is not the way that we can solve problems. In silos, we cannot solve problems in silos. And this competition is running at the moment, and it's actually a cybernetics simulation game. 16 schools in Adelaide are involved at the moment, and we had a meeting yesterday with the speaker, and we are going to have the finals hopefully in Parliament, in the chamber, and that will be in November, and we hope to roll this out to the rest. We only started as a pilot project in Adelaide with 16 schools, and we hope to roll it out to the rest of Adelaide and the rest of South Australia next year. The winners actually get tickets, three winners, there's 3 in the team plus the teacher, get airline tickets to Vietnam, where they will take part in the first international eco policy aid, where the winners are Germany, Netherlands, various other countries, one school from Adelaide will actually compete against all these countries. So, new way of thinking can change the effectiveness of government departments, businesses, organizations, and communities. By having better mutual understanding of the diverse mental models of different stakeholders. Moving away from traditional linear thinking that leads to quick fixes and treatment of systems to long-lasting systemic solutions that address the root causes. The ability to collaboratively identify leverage points and systemic interventions to underpin systems-based strategic and operational plans, where and when to invest in the system. That is a big issue because most of our companies, our university, doesn't matter where we are, normally have a strategic plan with a string of recommendations that needs to be done without a good understanding of the interconnectedness of these different recommendations. Very often 14 or 15 recommendations could be brought down to 5 or 6, and all the others will fall in place automatically. Deep understanding of the interconnectedness between possible actions in order to develop efficient and cost-effective management strategies. A working knowledge of cutting-edge systems tools to test the outcomes of strategies, including identification of unintended consequences before they actually implement that. And these tools will be part of the courses that we will run for the MBA. Understanding the use of evolutionary learning laboratories to ensure an ongoing process of continuous co-learning and refinement of strategies to deal with complex issues of any nature, whether it's a business, management, health, an organizational issue, a family issue, a personal issue. Stephen Hawking said this would be the century of complexity. Thank you.
Any questions? Bob's still got the equipment running. Would be good to pick up. Alan? Alan?
I have a few, if that's all right. One thing that sort of comes across in just looking across the university is the notion of transdisciplinary complement, extend, replace, transdisciplinary? What's the relationship between those?
Well, but basically, when you go into theory of interconnectedness between everything, transdisciplinarity is an integral part of that. It's part of the theory, and it's almost an automatic thing that happens. You cannot think in any reductionist way anymore. And I know we talk about interdisciplinary. Interdisciplinary is fine, but we also have to talk about transdisciplinary when you talk about these things. And this is where, when you start developing these models, as I showed in that one, you have, that is only a model of, if I remember correctly, the model I had up there was just a tourism model, tourism management model of Katba, not the island as a whole. And that had economics in, it had agriculture in, social, education, and all sort of things. And you need to go across all these to solve problems. Very difficult in a university, because students come here and they say, especially if they get a course like systems thinking in practice, and they get a course as a faculty core, they have to do it. And they came here to become a dentist or a park ranger or something like that. They have no idea. And Naam has a lot of experience with that, because he taught the course in the school that I was head of at UQ. And they come there and they are absolutely unhappy about this, because this is not what they wanted to do. I want to become a dentist. However, as the program progresses, before it's halfway through, you just have an enormous awakening, how they suddenly see the value of this, and the value of, even if they are going to be a reductionist scientist for the rest of their lives, they still see where they fit. They actually fit into the bigger picture.
Ockie, thanks for your presentation. Very interesting. And I think certainly one weak spot to me you've highlighted with our current MBA is that I think we do deliver it as a collection of courses rather than work on the interconnectedness. And to give you an example is that I myself, who teach the accounting course, I would have limited knowledge of content and as well as pedagogy that is employed in other core courses of the MBA degree. And so as a consequence, for me, really what you highlighted, there's actually really missed opportunities in terms of how I could structure and design my course as so it can actually integrate into content and principles that people are introducing in other courses.
Yeah, that's one way, and that's very important. However, there are also the opportunity through the project and through the transformation. What's the course name?
On the system is the leadership journey.
Leadership journey.
Yes.
That course. There's opportunities there, and you will see they will come up, because the moment when they tackle a problem, and Naam is actually going to show you just very quickly a few of the problems that students have worked with, diverse students, and you will see that once you take the problem and you start unraveling the complexity, which is the first steps,
Yes.
you suddenly need the inputs of an accountant, of a financial someone, someone that has knowledge about animal diseases, and so on and so on.
Yes.
Our experience in the past was now in Japan, and he will show you some examples. In Japan, they deliberately took students, medical students, engineers, education, social students, and business students, and mixed them up. My experience with that was I introduced the course when I got to the first to UQ in the year 2000, and then I became the head of the school, and that course gave me all the problems of the world, not because I didn't offer it anymore, but as head of school, every single day there were students in my office saying they want to complain because they don't want to be part of that team. Because I'm not interested in animals' diseases, or I'm not interested in this engineering issue. I'm not interested in that. And all I said to them was, that's the real world. You stay where you are. And in every single case, without an exception, they all at the end said, my decision or my order was the right one, because they discovered how they can contribute. And because we need discipline, we are integrators, but we need discipline-focused people. Otherwise, we will lose depth, academic depth and scientific depth, and we need those people. However, we need to find ways in which, when we solve a problem, you will see, this is where they need me, and that will make you feel good.
I think another relevant thing to say there is universities aren't set up as complex systems, so they are very siloed, not just in academic, but certainly in administrative. So when you're teaching or us in this area, there will be frustrations where you won't be able to easily do that interconnecting, and you just have to find another way. So my example personally would be starting at SEIC, coming in to do complexity from that, but the engineering I didn't fit there. Doing cognitive complexity, I had too much of an engineering complexity base to fit in psych, and eventually, so I had to find a way to fit in management, which allowed me to do requisite complexity, scientific, and now I'm starting to be able to do cross-disciplinary research. But that's really finding ways to push that capacity, because the administration doesn't allow me to do that. I have to find a loophole through. And as long as we know that at the beginning, that sometimes it will be very frustrating, but we can do the rest.
Yeah.
And there's a great example of how the winner takes all. If you remember Yahoo, and then came Google. Yahoo was based on a hierarchical search system. Not Google. Google has allowed their algorithm has been able to search a very complex environment through the internet. Something that Yahoo was not structured to do so. And Yahoo is only now making money out of all their entertainment side, nothing to do with the search engine.
Yeah.
So you can break those things down. You need that tipping point. Google found the tipping point. And we're going to try and find the tipping point here through
Yeah.
this process.
So I can certainly understand in terms of introduction in the first core course, or what is one of them being systems thinking, setting up, and really the capstone at the end in terms of really bringing all the discipline-specific issues into the depth of knowledge to a complex scenario,
Yeah.
which UNI's been involved in a lot in terms of overseeing, in terms of those business projects. So I think that's really, really exciting. I suppose I'm keen to explore in terms of within those silos, in terms of how we can still cross-link and stuff. So for example, I think I can probably work with marketing, for example, actually understanding in terms of financial information that assists marketers in terms of decision making, because of pricing and product mix and so forth. But today we really haven't had the opportunity to actually really share stories in terms of what our journeys are within the individual core courses, and how we can actually
Yeah, I think that we need that opportunity before we actually embark on that integration courses, the learning journey and the project. We need to have that kind of workshop, dialogue between the different groups. But I wonder, it's not going to take very long if Naam could show you just some of the projects that students have done. And remember that these students come from law and business and engineering and health and whatever. And that will give you an idea of the diversity of these things.
While he's setting up, I think it's important to note that what we're trying to do is actually a work in progress. And we're actually sort of a bit out on the edge here, so we're going to be doing it by ourselves. So expect things to be less than perfect. I don't have a problem with that. I'd rather be on this journey than not be on it. But I think this is a lot of it's going to be our own way of trying to deal with all these things. So let's enjoy the journey.
Or even things like visibility of what we need to do, so it's not yours. We can get that ourselves. Like we're going, and someone's going to have to.
Yeah.
We have to do things like just meeting and sharing and having
Yeah.
because otherwise we just won't get that information.
No,
ourselves. Let us.
No.
Sorry about my phone, folks. My iPhone's been sent away and I don't know how to use that stuff. I forgot.
You're regressing.
I'm regressing and I just don't know how to use it.
The fine is 3 balls of bread.
Well, pay.
Would you like to top it up before I start? Or?
Yeah.
Yeah.
Send it around. Send it around.
This is the full, so I keep this one and this is empty, so we have this.
It's
Open it up.
I would have
As Ockie said that we are going to be here until 12, but I promise that be very fast. About 10 minutes and then you can go home. Can you hear me? Or? Okay, so what I would like to share with you is at UQ there's an entity called Teaching and Education Development Institute, TEDD, which every semester they would conduct the evaluation of the courses and lecturer and then ask them about what they think about the course. So this is some feedback that they give us at the end. And also I would like to show some of the projects for students. So very quickly, I believe a course like this should be a core course in all disciplines and degrees, as Ockie mentioned before.
Now, may I just ask you a very
Yes.
quick question?
Yeah.
What type of students are they? You might have said and I missed it. Are they MBAs, undergrad?
They're all different. So this is
Okay, thanks.
from both undergrad and postgrad.
Thank you.
Yeah. And this is independently done, so we're not allowed to do it. TEDD come in and they do it.
Understand.
Yeah. Assistant King was a great course and it gave me a lot of insight. So quickly, this improved the way we perceive the world. It's a really good tool for my life and I can be applied in almost any context. It is very relevant and one of the most favorite courses throughout my degree. Couple of more feedback. Because we done it both internal, external. There's this student from PNG. She took a course as a remote student. She said that is really good for external students. She learned, enjoy more than she expected. This is most of the useful course ever taught at UQ. This one said that I've learned a lot from the course. The first course as mind-boggling and internationally stimulating. And then another thing said that I'm applying it, system thinking, in all areas of my life. So that's just there's a lot, but I would like to stop there and move on to some examples of projects. There are 10 of them, but I said that I'm going to spend maybe 1 to 2 minutes only on each. The idea is to share with you how it is applied in the diverse context and location as well. So, starting with something close to home. This is what 3 students worked on the issue of the what's called Black Saturday back in 2009 Victoria with a good file. So I'm going to be very fast. They look at the background of the problem, the conditions at the time, the management background, different structures, the key variables in the system, and then they get the definition, description of the variables. One or two, Ockie said, BOT or behavior over time, how different key variables change over time. Come up with some causal loop diagram and different key loops in the system, 5 key loops, the fuel load, management action at the time, community awareness, the mental models, different policy makers at the time. And then they came up with different average point system and what could be done. So that is one of the examples. The second example, I would like to take you to Singapore. They are working on the problem or issue of how Singapore can have enough water to supply for the population and so the number of visitors that come into Singapore every year. Even the fact that this country is small and most of the water is supplied from Malaysia. So this is the research questions. They use the 4-level thinking as a framework in their project, giving some information about the country. This is Singapore in 1960s, in the river systems, the mental model of the leader in the 70s, Lee Kuan Yew, the Prime Minister, and then this is Singapore in 2010 with their river system. And also the mental models, the thinking, the actions of the leaders, and introduce different sources of water that Singapore can have from. So I'm going to skip through all that, just information. The third sources, the fourth, and the big picture of the system. The cause loop, about water supply, different places that can be intervened to make the system better, key BOTs, water demand loops, again some other system tools, BOTs, climate loops, and they skip to that conclusions. Another example, moving to Chile, they've been working on the problem of public housing in Chile, in Santiago. So they get some introductions about the problem. Different headlines issues in newspapers. The scope of their study, the trends or the behavior over time of different key factors or variables in systems. The cause loop diagrams, different system archetypes. From that they were able to identify where in the system that they can recommend intervention. Fix not fail, success to the successful another system archetype. Some of the key insights that they learned from the project, the mental models. Another project which is close to Chile is the problem of deforestation in Brazil. So this one is looking at what was the problem, where the place, and why is the problem, and who are involved in the systems. and then different phase land use in the area, infrastructure as a starting point of deforestation, pardon me, and then BOT, different closed loop diagram, the key loops in the system, the mental models, the key insights that they've learned from doing the project. So we just skip all of that. Another one quite interesting is the impact of the global finance crisis on the real estate market in Dubai. So this is just the content of the presentation with the story, the Dubai economy, some background information, the real estate bubble and busts, and the dilemma. Key variables that they have identified in the system, and behave over time, how different variables have changed. Closed loop diagram, different key loops, migrations, fixed that fail archetype, the economy loop, the extension of that, the real estate demand and supply loop, the mental models of leaders, the government, and also the mental models of different stakeholders in the system, such as immigrant, foreign direct investor, and economists. Leverage points and different strategy that can be used. Another one is in Africa, looking at the problem of oil and corruption. This is the background to the project that I was working on. Demand for oil, three key components of the system: oil dependent corruptions and the power of multinational companies. And it's the finding of the closed loop diagram, different key loops. So we just skip to different places in the system that can be intervened. Coming back to Australia, another interesting one is the problem of child obesity in Australia. It's not only the social problem, but you can see this is context of the problem or the issue under consideration. The view over time of the key variables. The closed loop diagram, which have different key factors: parents, the influence, physical health, mental health, advertising, cultural influence, government response, society, family norms, the impact of media on the way to think children, the way they think, the way they eat, and the way they would like to be, the perception of the public, and having all of that they came up with different leverage point and possible intervention that can be done to solve the problem. In school, in learning, this is quite an international project looking on the impact of climate change on food security. outline introductions. Also behavior over time of different key variables in the system. This is quite a long one, so I'm going to skip all of that. They're just giving the definition to the key variables that they use in their system. BOT, and then they came up with different closed loop diagrams: animal progression loop, agriculture loop, fishery loop, deforestation, carbon sink loop, food access loop, food utilization loop, and then other things is, and the mental models, perception of public, and then also mental models of powerful nation in the world, thing in the news. The leverage point, and then what can be done. So it's going to skip through all that. So learning what they've learned is the same person, but after learning through the process, you see the problem with different angle, even though that's the same person. The more recent one that Ockie and me, as Ockie said before, that we went to teach in Japan for 3 intensive days. And this is one of the projects. Over there, they before we came, they already sent students out to the company and government, and they come up with real problem or issue in different companies. This is one of the projects looking at unemployment in Japan. This is students from all different backgrounds. Look at the problem of what they're going to need, not in employment, education, or training, similar to people, unemployed people in Australia. So their key questions in the project is how can they avoid their children to become the needs of tomorrow. So they also use closed loop diagram, different key loops in their system, and they identify the key leverage point system, which they use Bayesian network BBN to develop the model for that. It's the first draft of the model. This is a table that they use to populate the model. And from that, they were able to identify another key play system, and they're in the process of having another model for that. And actually, Ockie and me are working with, there were 12 groups, and we chose 3 groups of them because they're really good, and we are working with them to develop their project into paper. So that's another good way of combining teaching and research. So 3 groups has been chosen, and we are working with them in terms of turning it into one of the paper. The last one, international learning activities, which require something to do with Japanese people. This is the last one. And so they gave the background to the problem, the behavior over time, the daily amount of meat supply in Japan per person per day. That is linked to the closed loop diagram of the whole system, and then different key loops in the system. The mental models of anti-learning people.
Hey Stan, I heard you're looking for people who who care about the Japanese slaughtering whales.
Yeah, Butters, you want to help?
No, I got stuff to do. But I wanted to tell you, there's these fellers on TV. They go out in the ocean and try to stop the Japanese wherever they are.
Really? People who are doing something?
I watch your show all the time. And they take volunteers.
Then that's where I belong.
So I would like to end my thing here because it's very, very short. I would like to show how it can be applied in different contexts and also different locations. Thank you very much.